23. How many zeros are needed to write the diameter of the sun in standard notation? Okay, so the diameter of the sun is 1.4 times 10 to the 9th. So 1.4 times 10 to the 9th. We need to move it 9 spaces. It's positive, so it's to the right. So 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So how many zeros is that? That would be 8 zeros. Now, we could also look at that as saying we need to move it 9 times. Well, once we move it once, now we need to start adding zeros. We need to move it 8 more times. And if we need to move it 8 more times, we're going to need to put in 8 zeros. On to 14. I'm sorry, no. On to 24. Write the diameter of the transistor in standard notation. So the transistor is 1.6 times 10 to the negative 5th. So 1.6 times 10 to the negative 5th. 1.6, the negative tells us we're making it smaller and we need to move it 5 times. So 1, now we need to start adding zeros, 2, 3, 4, 5. So it is 0.1, 2, 3, 4 zeros, and then 16. 25. How many digits are there in the standard notation for the height of Mount Everest? So Mount Everest is 8.9 times 10 to the 3rd. So you'd have 8.9 and you need to move it 3 times to the right. So you'd get 8,900 meters. And how many digits is that? 1, 2, 3, 4. On to 26. An object is 100 times greater than the grain of sand. Describe the size of this object in scientific notation. Okay. So grain of sand. I think they mean grain of salt. That's supposed to be salt. Well, a grain of salt is 1.6 times 10 to the negative 4th. So 1.6 times 10 to the negative 4th. If we write that out, we would get we would get this number. It's 100 times greater, so we're going to multiply that by 100. When we multiply by 100, we're just moving the decimal twice to the right. So we would get 0.016. This number in scientific notation. Our base is 1.6, and we multiply by 10 to the negative 2nd power. So this object in scientific notation would be 1.6 times 10 to the negative 2nd power. Now we can see that our original grain of salt is 1.6 times 10 to the negative 4th. What we got was 1.6 times 10 to the negative 2nd. So we increased it by a power of 10 to the 2nd. So our original size of 1.6 times 10 to the negative 4th, we increased this by 10 to the 2nd power, which would give us, if we increase that by 2, the exponent by 2, we'd get 1.6 times 10 to the negative 2nd. All right, 27. Arrange the numbers in order from greatest to least. All right, so greatest to least here. So 4.3 repeating, that's still 4.3 repeating. This number would be 3.14 over 4. So this is actually less than 1. So we don't even need to write that out. We know that this is less than 1. So whatever this is, it's less than 1. Square root of 75, the two closest perfect squares are the square root of 64 and the square root of 81. Square root of 64 is 8, square root of 81 is 9, so this is somewhere between 8 and 9. So let's just label that 8 point, not really anywhere, 5. And then this 20 over 13, 20 divided by 13, 13 goes into 20, not even 2 times, it'd be 1 point something. So 1 point, we could almost put anything we wanted here. 1 point, let's put 1.6. So this is 4.3. We know this is less than 1. This is around 8.5, and this is 1.6. So which one's the greatest? Well, the greatest number here would be 8.5. So square root of 75. What's next? Next, we would have 4.3 repeating. Now we're left with 20 over 3, which is right around 1.6, and pi over 4, which is less than 1. So since 20 over 13 is greater than 1, it's greater than pi over 4, and the last one is pi over 4. On to 28. Write the answer in scientific notation. So I'm going to rewrite these so that they have this same denominator, or not same denominator, same power of 10. So we have 5.1 times 10 to the 7th. We need to increase this to a 7. So to increase the exponent, we have to decrease our base. So this will become 0.13 times 10 to the 7th. And I'll rewrite that. 5.1. And I need another decimal times 10 to the 7th plus 0.13 times 10 to the 7th. They have the same power of 10, so now we can add them. So when we add this, we're going to get times 10 to the 7th. 0 plus 3 is 3. 1 plus 1 is 2. Bring down the decimal. 5 plus 0 is 5. So we get 5.23 times 10 to the 7th. So we get 5.23 times 10 to the 7th power.